This is the lecture for CS225, Module 7, Java FX Basics. So we're moving into GUI development in terms of how to do that in the Java programming language. And Java uses something called Java FX. That's the latest form of the GUI. And here are the outcomes, as always. At the end of the module, come back to these, please. Convince yourself that you understand these outcomes. And before we get into the details here, let's talk about the model view controller pattern. A pattern is a common structure given to programs in object-oriented languages. And you can Google Java patterns and find out all about them. The one we're dealing with right now is called the model view controller pattern. And what the model view controller pattern says is there are effectively three parts to your software, to your program. One part is the view. That's the GUI. That's the thing that's shown to the user on the screen. But the other part, and I argue the more important part, is the model. That's the actual data, the actual math models that performs your analysis or runs the game or makes a simulation happen. These are your objects. Remember, objects are attributes and methods. These are your objects with their attributes that are actually keeping track of program state. All the view is doing is showing that program state to the user. And these two things need to talk to each other. And the way that they talk to each other is through the controller. So the GUI typically has some kind of a widget in it that will allow the user to have some interaction with the program. And when the user clicks a button or fills in a text field or does a key press or a mouse click, that's a GUI interaction, but what it does is it fires off the controller. So the GUI will tell the controller, hey, the user just requested something to happen. And then the controller will tell the model, here's the request, model, update yourself. The model does whatever it's supposed to do, and then the view will be revised based on the updated model. So in a typical, let's do our sheep-sheepdog game example again. If the user wants to move the dog, maybe I'll use the left, right, up, down arrow keys to move the dog. And if the user clicks the left arrow key, that's a GUI interaction. The GUI will tell the controller, hey, the user wants to turn the dog to the left. The controller will tell the model, hey, model, you've got a dog object in there somewhere. Turn it to the left. And then the view will be updated to show that the dog actually turned to the left. It's a loop that keeps going on over and over and over. Now, it doesn't have to be in a game form. It happens in real time, kind of like an animation. It doesn't have to be that way. If you want to do, say, a statistical analysis of some scenario, you set up the scenario through the GUI, and then you click the calculate or run simulation button, and the controller will take all of the data that you put into the GUI, pass it down to the model and say, okay, model, here's the scenario, here's all the attribute values you have to work with, and now go do your analysis. The thing to remember, and it is difficult to get a hold of because of our real-world experience doesn't intuitively give this insight to us, is that the thing you see on the screen is absolutely not the thing, it's just the representation of the thing. So if we look at the sheep-sheepdog game, for example, and I presented this simplistic display earlier on in the semester, and it's a perfectly fine display for the sheep-sheepdog game. It's perfectly fine level of detail that you can use in your projects. And I said, okay, those white things are the sheep and the brown and the gray thing is a dog. And actually that's not quite true. I was kind of lying to you there. What I was saying was we need to create sheep objects. We need to create dog objects. But those are not sheep objects and dog objects. They're just white ovals and gray ovals on the screen. So they're not sheep. They're the view of the sheep. The actual sheep we talked about last week when we looked at UML diagrams. The actual sheep are a class here, and they have their attributes, x location, y location, x speed, y speed, max speed. That's what the sheep actually is. That's the real sheep. The circle you see on the screen is just showing you the X location, Y location. And if they're moving, it's just showing you the speed and the direction. But the actual values for those come down here. So all of the sheep behavior resides in the sheep model. And what you see on the screen is a representation of that behavior. So the model is everything that's away from the GUI. The view is just literally the GUI, the stuff you see on the screen. The controller kind of straddles a few worlds, and I might even, claim that you could put part of the controller in the model. You could do something like that because it does interact with the model so intimately, but it also interacts with the GUI intimately because it's the go-between. So the controller is really closely tied to the GUI because the GUI elements are going to call out the methods in the controller. Hey, here's a request. Make the dog speed up. And then the controller has to pass that request along to the model. Hey, dog, speed up. Okay? So now we can talk about how to actually create GUIs in JavaFX. And I would like to remind you, the things we're going to talk about, these are just basic graphical elements. These are not the kind of things that you want to make your beautiful 3D ray traced with proper physics and proper shading, three-dimensional dungeon mazes with. You're not going to make Call of Duty level graphics with this kind of thing. This is just basic GUI elements. In order to make those really sophisticated things, you use other pieces of software. If you tried to do it from scratch in Java, it would take years because it took years to develop those other pieces of software. You're not going to use them in this course, but if you want to make beautiful three-dimensional models and castles that you can walk through and things like that, then you want to use things like Blender and Unity. These are engines that are out there, gaming engines and simulation engines that are out there that you can use. These are just going to be basic circles, squares, text boxes, things like that. The course requires JavaFX is used for your GUI elements. So in your project, you have to use JavaFX. When Java was initially put out, they used something called an Abstract Windows Toolkit, AWT. Everybody hated it, so they changed it after a while. They went to Java Swing. Many people hated it, and now they're on FX. So far, it doesn't seem like too many people hate FX. Now, I remind you, the GUI I/O for any input-output for any programming language is always the ugliest thing. Making a GUI is always the ugliest thing in terms of coding. It's going to have a lot of lines of code just to make sure that your buttons are in the right spot on the screen, make sure that the boxes and text boxes are on the right spot on the screen, that kind of stuff. So it's still relatively ugly, but it's better than it was. Now, also, I'm strongly encouraging you when you're doing your project or when you're doing your Hare and Hound homeworks that you Google specific graphical elements. That's the best way to find out how to use them. And make sure to include FX in the search when you're Googling. Otherwise, you might pull in by accident an old article about how to use Swing or an even older article about how to use AWT, and you don't want that. When you're importing things, when you're bringing in these things to use into your program, definitely make sure it's JavaFX. Okay, the FX was designed to have a rough equivalence to this a notion of a theater. So what does a theater have? A theater has a stage. And what can you do on the stage? You can change out the scenes. And then it starts to get a little fuzzier from there. If you were to take that scene and cut it up into portions where each part of the scene was looked through say, a pane of a window, then you would have a pane. So what you have is a stage. It's literally called a stage. And inside that stage, you put a scene. And inside that scene, you can put different window panes in order to have visibility into different parts. And we'll talk about why that makes sense. Within the panes, then you put the actual visual elements. These are called nodes. It's the generic term for them. Nodes are things like images and text boxes and radio buttons and even other panes. You can put panes inside of panes. So the pane is what the user sees through for the GUI. There's a bunch of different types, and we'll go over them in have examples in code for each of these. They often contain other panes, and yes, I have examples of how to put panes in other panes, and I will present them as much as class time allows, but I will put all the code up there for you. The other nodes that you tend to have are text fields and labels. Text and labels are both text presented on the screen. A text field is actually a box where the user can enter text, and there's also something called a text area, which is a multi-line text field. Buttons that user clicks to make things happen, images, other controls like sliders, menus, drop-down boxes, radio buttons, check boxes. And on top of that, virtually every node element can actually become an active element. So for example, you could have an image, but that image, if you click on it, also serves as a button. You can have a circle or a pane, and if you click on it, you can make something happen. And as we'll see, there are probably a couple hundred different methods associated with all of these. You'll use like 2 or 3. But you can do really fancy stuff if you have to. Like even you can do things like if the mouse goes over the circle, something happens. And when the mouse comes away from the circle, something happens. When you click on the pane, something happens. When you click on another pane, something else happens, right? So you get the idea. You can get a lot of interaction here. We're not doing the interaction this week. All we're doing is presenting. So what we have, the previous few weeks we've talked about basically the model. Now we're talking about the view. What we haven't done yet is how to link them together with a controller. That's going to happen next week. So just be aware, this is all presentation and nothing happening. Okay, so some simple examples here. Now we have the code for this, but I'm just going to focus on the visual presentation. Going through stage, scene, pane, nodes. The stage is the entire window that you create, and that includes all of I'm working in a Windows environment. You know, the Mac environment is the same. It has a ribbon on the top that has some of the window controls. So it has the title and the minimize and the maximize and the quit or end button widgets. That's all part of the stage. Underneath that is the actual content of the window, and that's the scene. Now this scene only has one pane in it, so it's not broken up into smaller panes. And so you can't see the pane, that's the thing you see through. And then we have the nodes, the text, R1, R2, R3, those are labels or text. I'm not sure which they used, we'll have to look at the code. These are rectangles, these are rectangles. And so what you're seeing here is the stage. Inside the stage is the scene, inside the scene is the pane, inside the pane is the nodes. And this whole Russian nesting doll thing is something to get used to. So its stage contains the scene. I think of them as containers. The stage contains the scene contains the pane. A pane may contain other panes, and then the panes contain the nodes. And I'm going to stop here and then start looking at some code. I'm not going to go through a lot of code walkthrough here because you have the examples and we're doing that in the live lectures. So it's much better in the live lectures when I'm actually executing code and playing around with it. As always, I recommend that you download the code, run it, and break it and change it and fix it back. And that's the best way you're going to learn these things.